Hey everybody, today we are going to talk about linear regression. It goes more with our lines, so it's a little bit off of what we've been doing, but it's a pretty easy concept and a pretty easy Friday for you to have while I am not here. All right, so we're going to do this worksheet together, and then you're going to do a separate worksheet on your own and turn it in. Here we go. Farmer Jones was preparing his turkeys for the big Thanksgiving rush. He decided to count the feathers as well as weigh each turkey for sale. He gathered the following data. So he has the weight of the turkey and he has how many feathers the turkey had. I want just to graph the points on the coordinate. The first point is already there. So the point 8, 3, 12 was already here. We're going to do the point 9 and 321. We're going to guesstimate. So each of these looks to be 100. So, and these look like they are each to be 5. All right, so 9, 321, 10, 350. We're just making our best guess here. 12, about 401, 14, and 435-ish. 15 and 468, 16 and exactly 500, 17 and a little bit, 499 goes down, 18 and 519, a little bit above, 20 and 562, 21 and 571, 22 and 607, so above here, 25 and 665. Okay, those are all of our points. So we're using our best guess. It's not a perfect line. It kind of goes up and down. It's a little wobbly, but that's what happens when you have real data. Real data doesn't usually give you a perfect line. So here we go. So we have a table of values, and then we also graphed our points on a line. All right, the equation of the line of best fit that models the data is y equals 20x plus 147.3. Okay, it wants us to interpret the real world meaning of both the slope and the y-intercept, and is the y-intercept viable? Okay, so back at our table, our input is our pounds and our output is our feathers. So it's saying the amount of feathers depend on the weight of the turkey. So according to this, remember, slope is going to be change in y over change in x, right? My slope right now is 20 over 1. So that's saying for every 1 pound, so each 1 pound of turkey has about 20 feathers, is what that slope is saying. So each time we go up in weight by a pound, we are also increasing by 20 feathers. The y-intercept is the 147.3, so that's 0, 147.3. Remember, this is my x, this is my y. So if x is 0, so if it's saying if my turkey is 0 pounds, then it's going to have 147.3 feathers. Okay, is that viable? No. Because if my turkey doesn't weigh anything, then I don't have a turkey. So if I don't have a turkey, we're not going to have feathers. Okay, so if there's no pounds, we don't have a turkey, we're not going to have any feathers to go with it. Okay, so that is not viable. That does not make sense in the real world. All right, predict how many feathers a 1 pound turkey is going to have. So what it wants me to do is take the equation of 20x plus 147.3 and it wants me to plug in a 1 for X because that's my pounds. So 1 pound plus 147.3. 20 times 1 is 20. And then if we add 147.3, we're going to predict that a 1 pound turkey, what is that, 167.3? So a 1 pound turkey will have about 167.3 feathers. All right, part C. He forgot to weigh a turkey that had 553 feathers. How much did it probably weigh? All right, so we're going to kind of work backwards here. So we know how many feathers we have. We know it had 553 feathers. So what we don't know is how much it weighed. So we're going to set this equal to 20x plus 147.3. And we're going to solve for X, which means we're going to solve for the weight of the turkey. We're going to kind of guess, use our, see the trend that was going on, and we're going to use that to help us solve. So to get X by itself, we're going to subtract 147.3. So 553 minus 147.3 is going to give me 405.7 equals 20x. And then I'm going to divide 405.7. I'm going to divide that by 20. And divide by 20, divide by 20. 405.7 divide by 20. I am getting a weight of about 20.285. So the turkey probably weighed, probably weighed about 20.285 pounds. Okay. Explain why this graph would not be accurate to predict the weight of a turkey with 1,000 feathers. Well, the graph is giving me actual data, and it doesn't show me that far. It only goes up to 30 pounds. It only goes up to 800 feathers. So it's really out of our constraints. It's out of our window. So like 1,000 feathers is really too much. 1,000 feathers, I'm going to say out of window. It's not going to fit on this graph. Out of window. Okay, it's too big for us to predict with the information that was given to us. I mean, we only have it in those 665 feathers. 1,000 is just too far away. Okay, so that's why our graph's not going to help me. The correlation coefficient R equals 0.99. What does R tell us? Okay, so 0.99. This is a very, it's a positive number. Okay, so it's a positive correlation, and it's very strong. So when it comes to correlation, the closer to 1, the better. And if you look at the dots that we put on here, I mean, that was almost a perfect line. Okay, so the closer this is to a perfect line, the closer it's going to be to the number 1. And with it being positive, it just means that our line is increasing. We have a positive slope. So we are increasing in value. So R equals 0.99 shows a very strong positive correlation between feathers and weight. Positive, very strong correlation between feathers and weight. So let's do another example. Here we go. We have food. We have one serving of different Thanksgiving food. We have the fat in grams, and we have the calories. Part A, is there a positive, negative, or no association between the fat and the calories in this food? Okay, so let's look. Let's see, 11 grams of fat, 340 calories. I would assume that there's really no association. It's kind of all over the place. So I'm going to say no association. I don't see a trend going on. Like, I don't see it increase. I don't see the calories increasing as the fat increases. I don't see it decreasing in any way. Because look right here, 4 grams is 165 calories, but then 4 grams is also 305 calories. So they're kind of all over the place. Part B, plot the points on the graph below. Okay, so here's our graph. Here we go. Fat and grams. Let's do our first one. So 11 and 340. 11, 340 is about right here. 4 and 165. About right here. Then we have 4 and 305. Okay, it's up here. 3 and 185. In between. 10 and 250. 11 and 135. It's going to be down here. 0 and 100. And then 20 and 310. That right here. All right. So there's our dots. The line of best fit that models this relationship is y equals 161.61 plus 7.89x. Interpret the slope in the context of this problem. Okay, so again, slope is change in y over change in x. According to my table, that is calories over fat. So this is showing 7.89 over 1 for my slope. So it's saying for each gram of fat, the calories are going to increase by 7.89. So that's how we interpret the slope. Does it make sense to interpret the y-intercept? If so, do it. If not, say why. All right, the y-intercept in this case is 0 and 161.61. It's saying, I guess we can interpret the y-intercept. So again, x is fat, y is calories. So it's saying a food with 0 grams of fat has about 161.61 calories. All right, how many calories would you expect to be in a pecan pie, which has 27 grams of fat? Okay, so grams of fat, remember this is our x values. So we're going to use 27 for x in the equation they gave us above here. 161.61 plus 7.89 x, which in this case is going to be 27. All right, so let's figure that out. So I'm going to multiply first. 7.89 times 27. That is going to give me 213.03. And now I am going to add that to 161.61. And I'm going to get about 374.64. So we're going to predict about 374.64 calories. And pecan pie. All right, part E, R equals 0.56. What does this tell us about the relationship between fat and calories in this food? Okay, so we know it's a positive number, so there's a positive correlation. Just means that it increases. Remember I said earlier, the closer to 1, the better. 0.56 is only halfway to 1, right? So this is a very weak correlation. Okay, look at our plot. Look at our scatter plot. My points are kind of everywhere, right? These do not make a line like we did. Compare that to what we did earlier. I mean, that was almost perfect, right? This one, they are everywhere. There is no shape. There is no correlation. It is very weak, okay? So this is going to show no relationship or a very weak relationship. Relationship between fat and calories. All right, this last little bit wants us to determine whether each set of data, would have a positive, negative, or no association. Okay, so the number of dinner guests versus the size of a turkey. Well, if you have more people, that's more people to eat, right? So I would say this has a positive because more people you have, you're going to need a bigger turkey. So it would be a positive association. The number of people eating versus the amount of leftovers. Well, the more people eat, the more food you are going to get consumed. So hopefully you have less leftovers. So this is going to be a negative association. The more people you have, the less leftovers. Score of a football game versus number of pies for dessert. That is no association. It does not matter. One of these is not going to affect the other. The volume of a parade balloon versus the time needed to fill it with helium. This is going to be, think about it, bigger the balloon, is it going to take more time or less time? It's going to take more time, so this is going to have a positive association. All right. Good job. All right, so you are going to use these notes to help complete the worksheet and turn in before you leave today. Thank you.